Retinal deposits an early warning signal for coronary artery disease, which is also known as the silent killer because it often comes without any symptoms. So early detection is crucial, and this can be done with CTCA and ICA. However, these methods are invasive because they use x-rays, and they are typically only available in large metropolitan hospitals because these machines are expensive and require expert input. So there is a need for a low-cost, accurate, but safe screening tool. You've asked about market size. Saving lives is a multi-billion-dollar industry. Our solution is retinal imaging with polarization-sensitive OCT. We've used this technology at Fiona Stanley Hospital to look at the thickness and the birefringence of the vessel walls of patients with various degrees of coronary artery disease. And in this study, we want to use the same technology to look at deposits in the retinal pigment epithelium Bruch's membrane. Why? Because we already have pilot data. Here you see 10 sets obtained around the optic nerve of 10 non-attentive subjects, and all of the signal here is blue, meaning there are no deposits. Subject 2 seems to be out of place. Probably fits better in this cohort of hypertensives, where you see these yellow eye retardance spots. We think these are deposits induced by a process similar to atherosclerosis. And in patients with coronary artery disease, we expect to see more of them with higher values. So our value proposition is a 4-second painless non-invasive retinal scan for the early detection of coronary artery disease, which can be used in GP offices and rural clinics. This promises to give better health outcomes and lower healthcare costs. Our competition is MediWill, Google DeepMind, and Tulku. They look at two-dimensional fundus images and rely on artificial intelligence to predict cardiovascular risk. That's a black box. We, on the other hand, use three-dimensional data obtained with polarized light, and our goal is to understand the relationship between measured signal and underlying physiology. For this reason, we want to look at animal models as well. This is not a black box. How are we going to make money with this? We founded CAT Spectral Technologies to sell PSOCT for the detection of coronary artery disease, and we are currently preparing a patent application looking at the vessel walls. In this study, we are going to look at deposits. The combination of these two hopefully leads to 100% sensitivity and specificity. It will certainly lead to new IP. And we also plan to collaborate with PSOCT manufacturers. Currently, that's only Toumai. Alif Medical and Heidelberg are on the fence, and we want to license the technology. Our technology is currently at IML4. At the end of this project, it will be at IML5. And at the end of everything, you guessed it, it's going to be at IML9. Thank you for your attention.